Hello, builders, and welcome to Building SaaS on AWS. My name is Anthony McClure, and I am a solutions architect with the AWS SaaS Factory who's bringing you this show today. If you are currently a builder of software as a service solutions, or even just getting started learning how to design, build, deploy, and operate applications in multi-tenant environments, then this is the show for you. In every episode, we strive to bring you in-depth topics related to software as a service and bring in subject matter experts that can dive deep into those topics with you as well. Today's show, we actually have some great guests that are coming in with us to talk about a topic that is really important and something that we hear all the time from virtually every customer that we interact with. And that is, how do you attribute or figure out how much each one of the tenants in your applications actually costs you? This is really important for numerous different reasons, including figuring out the cost of goods sold, these financial metrics that many times our financial organizations want to know, as well as to help to build out your pricing infrastructure, understanding what you're planning for your solution growing into the future, so many other reasons. But as we will see, there's really no magic bullet to really help us to do this. But the SaaS Factory has been working together along with others to build out solutions to help make this a little bit easier, at least show you how it should be done. But before we jump into today's content, I do want to welcome everybody that is joining us here live today on Twitch. Welcome to the show. If you are live with us today, please jump into the comments section and say hello once again to Bill Tarr, who is acting as our moderator for today. Also, if you have any questions or comments for us related to the show, for myself, for the guests, please make sure and put those into the comments section as well. We love to interact with our audience and to have that interaction going. While you're there, I would also ask if you like this kind of content, you want to see AWS continue to bring you these kinds of shows, make sure and hit that follow button. It's one of the best ways to show AWS that you appreciate what it is that we're working on here. If you are joining us later, a video on demand on our YouTube channel, be sure to like, subscribe, and hit the notification bell if you want to get notified of all of the great content that we're bringing you to. So, without further ado, why don't we go ahead and jump into today's topic? And to help us do that, I'm going to bring on the first of our guests and introduce Babak Parvisi. Babak, welcome to the show. Babak, it looks like your camera got a little bit blurry there for some reason. I'm not sure what's going on, but hey, welcome anyway.
I'm not sure either. Maybe it hasn't.
You're blurred out.
Maybe he hasn't had his coffee yet.
Yeah. No. You're in the witness protection program. Maybe that's what's good.
Okay, maybe I'll try to clear it up here. I don't know exactly.
No worries. But okay. Welcome to the show. Why don't you introduce yourself, Babak, and tell us a little bit about the SaaS Factory?
Sure. My name is Babak Parvisi. I'm a solutions architect here with AWS SaaS Factory. And we help our customers and partners deliver SaaS on AWS. So whether that's developing new business capabilities, migrating existing ones, or in a lot of cases, just helping them to optimize solutions that are already running on AWS. And so our team provides both technical and business enablement. You'll get access to both a business and a solutions architect to help you along with your SaaS journey. So sorry, I'm blurry here. I'm not sure what's going to happen. Let me stop my camera and come back on again. I'm not sure, but we'll go ahead and pass it off. So let me.
No worries. Thank you, Babak. Yeah. So next, I'd like to go to bring in our second guest as well, Mahesh. Welcome to the stream. Mahesh is a principal solutions architect with AWS India. Mahesh, want to introduce yourself?
Hey, thanks, Anthony. Good morning, good afternoon, and good evening, depending upon wherever you are. Myself, Maheshwaran. I'm ISV Principal Solution Architect based out of Bangalore, India. So in my capacity, I work with ISVs in India and help them to transform their SaaS products, which in turn help them to achieve the business goals to improve their top line growth as well as improve their margins. Happy to be part of this Twitch show, and I hope we will be able to add value to your time. Thank you.
Oh, well, thank you so much for being here with us, Mahesh. I really appreciate you being on the show. And last but certainly not least, I would like to introduce to the show Anubhav Sharma, a veteran of the show many times in the past. Anubhav is a principal solutions architect with the SaaS Factory. Anubhav, want to introduce yourself?
Yeah, sure. Thanks a lot, Anthony. So I'm a principal solutions architect from the SaaS Factory team, as Anthony mentioned, based out of Boston office. Nice fall weather out here today, and yeah, I mean, really excited to be part of this show. I mean, this is, as Anthony mentioned, a problem which many of our customers have been talking about, and we thought it would be really good to actually build some hands-on content. So the idea today will be actually to kind of take you through a preview of what we are presenting at reInvent actually. So we'll be talking
Nice.
about a workshop that we have been building for reInvent and doing a quick preview of that workshop and actually walk you through the approach that we are taking to solve this challenge.
Awesome. Very cool. Thank you so much as well for being here, Anubhav. And so, let's just go ahead and just dive right in, right? So why in the world are we hearing so much about cost per tenant, right? I mean, this is just something that comes up constantly. It's obviously a difficult subject, I think, for our customers to deal with. So why are we hearing so much, and why is it so important to our customers?
Yeah, so I started hearing about this. Obviously, this has been the concern from the very beginning when we started this team. I think it was in 2018-19 when Todd Golding wrote his first blog around how do you how do you think about measuring cost per tenant in a SaaS environment, right? So this has been a
Mhm.
challenge from the very beginning for SaaS providers to understand and get into the visibility of the cost per tenant. But what I'm seeing for last 2-3 years is that many of the SaaS providers are kind of using usage-based pricing. So what that
Mhm.
means is you basically charge your customers based upon the actual consumption. And what that really means is you really need to understand first of all the usage of your tenants and also how much AWS cost that usage is driving, right? So when you think from that perspective, you really are looking for understanding the expenditure of your tenants, right? And you're really trying to get to that profitability. You're trying to make sure that your pricing reflects the actual usage, right? So
Mhm.
it really becomes crucial for you to get to understand the usage footprint and the cost footprint of your tenant, right? So I know we are talking a lot about cost today, but we will be also kind of focusing on the usage footprint of tenants as well, Anthony. Yeah.
So when we break this down, right, and even kind of at a higher level than just cost per tenant, we're really still diving into this same topic we've been talking about for the last few episodes, right? And this whole concept of getting its per unit metrics and
Yep.
monitoring capability. Why is this so important from a business perspective?
Yeah, I think if you don't mind, I can share my screen,
Sure.
and I do have maybe some diagrams to talk about it as well. So by the way, first of all, right? So you're right. It's just not cost per tenant. It is cost per whatever measurable business outcome, right? And in
Mhm.
general, we call it that as cost per unit. So it could be cost of running a feature in your application, maybe cost of a tier, maybe cost per user, right? But the most common use case that we see is cost per tenant, basically, right? And so this workshop that I'm presenting you today, which I mentioned, is basically something that we will be doing at reInvent. So this is not really live yet. This is like a preview. We will share the link of the GitHub repository with you for today, which is public. But then this workshop link will be added to that GitHub repository, right? So when we build this workshop, we obviously started by talking about the problem statement, right? And as you can see, from business perspective, it is basically making sure that you are aware of your expenditure of your tenants, right? You're aware of the usage footprint of your tenants. um, Capturing the cost of tenants and cost of unit also gives you a way to optimize the cost, right? Which is again very crucial in today's environment. You really have pressure around margins, and you really want to make sure that your architecture is optimized in a way it's kind of making the best of the economies of scale, basically, right?
Mhm.
And then obviously I talked about profitability, and what I have seen customers doing is they bring their pricing data from Salesforce, and they bring this cost per tenant data and try to build charts for business teams, for finance teams, to kind of have a flavor or and kind of have a look that okay, how does my COGS relate to my pricing, right? And what's the profitability here?
So this would be
So
like building out dashboards to visualize that information.
exactly, and actually, I did like a lunch and learn session with a customer a few weeks back, where they actually walked us through how they build those dashboards as well, right? So it's a common pattern that we see where customers build dashboards to visualize this information, not just the cost, but also like bring the pricing data and kind of combine them together as well. Yeah. Yeah, Anthony, if you don't mind, maybe I can also, talk about the problem statement and maybe few other concepts as well.
Yeah,
Right?
absolutely.
Yeah.
Please. Yeah.
Yeah, I think so. When we talk about solving this challenge, there are few SaaS concepts that we need to be aware of, right? So to bring that picture into perspective, and I'll talk about those two concepts first, and then we will have Babak and Mahesh actually go through some code in terms of how
Excellent.
we solve the problem, and then I'll show some dashboards and visualizations and how we visualized the whole cost per tenant using QuickSight, right?
Sounds
But
great.
yeah, but before we kind of jump into those things, there are couple of things I want to mention, right? So the first of all, I want to bring the attention towards the two halves of SaaS application, right? Which is the application plane and the control plane. Application plane is basically the application which you are really offering to your end customer, right? This is the part which basically your end customers are leveraging. And then the control plane is basically the management footprint of your SaaS application, right? Your customers do not use this. This is for you as a SaaS provider to manage your application, right? The whole onboarding aspects, the billing and metering aspects, identity management, etc. Right? So keep this in mind. And then there's one more thing I want to mention is the two isolation models. I'm sure you must have seen this slide before, or may have may know about this concept, but it is very important in this discussion, right? So on the left side, we see a silo model. Basically, in this case, where each tenant have their own dedicated resources, right? And then on the right side is a pool model where tenants are sharing resources. Now, each
So
of
in just taking those two models into
yeah,
account, just looking at it, obviously, right? It's probably a lot easier, right, or at least an easier prospect of getting all of those metrics or an understanding of the cost when every tenant has their own infrastructure than it would be in the pooled model, I would imagine.
exactly right. And that's the whole point I talked about, the application control plane and those two isolation models, right? So if you think at a high level, now this is like a 10,000 feet level view, right? Um, you can easily determine the cost of your control plane and the cost of your silo tenants by just using cost allocation tags, right? So if you look at this diagram, um, you can just tag your shared resources by some sort of tags. Obviously, you can granularize and make it more granular as needed, but the point is that the cost of the control plane is a separate line item, right? You can figure that out using cost allocation tags. And you're absolutely right, Anthony, that even the cost of the silo tenants could be easily determined by using cost allocation tags, right? So this is
That would
not
then roll up into the Cost Explorer, right, for AWS, so that you can build from
exactly.
those.
You still need to enable the cost allocation tags, which I'll show you how to do that. But yes, I mean, once you do that, the cost and usage report will give you the breakdown of cost by tenant, or in other words, cost by tax, right? And it's not even a challenge. It's pretty straightforward in this scenario, right? The challenge that we see is this pool model where tenants are sharing resources, right? And here the challenge is that you really can't go more granular in terms of cost allocation tax, right? So you have to find some creative ways to get to that to that usage and cost footprint per tenant.
Yeah, there's no magic bullet for that one, right? No magic button you can hit to make those
Yeah,
happen.
exactly, right. And this is a challenge that we are focusing on in this workshop, to be very specific, right? And this is the crux of this workshop, and that's the whole point of setting the stage, like why you will be challenged to do this versus these, right?
Mhm.
So now focusing on that aspect, which I just talked about, how do you get the cost per tenant in a pool model? So this is the approach that we took. And this is the approach that we have seen other customers also taking, right? So the approach is that you basically somehow make your shared resources, which your tenants are sharing, tenant aware. And what I really mean by that is there should be some sort of way for each and every incoming request to identify which tenant is actually making that request, right?
Mm.
And then you start capturing some metrics in that in those microservices, and then you can aggregate those tenant consumption or tenant usage based upon those metrics, right? So in this case, based upon all these metrics that we might have generated, and we'll show you how to do that, right? Tenant 1 is at 20%, tenant 2 to 45%, tenant 3 at 35%, right? So this is, in my opinion, the harder part, right? The getting to the usage, and since each AWS service will be little different in terms of how you do it, right? So this bit definitely is a challenging part, and this workshop focuses on some good examples on how to do this, right? And then you also have your cost and usage report, which is basically a file that is generated by AWS on daily basis and delivered to you in an S3 bucket, right? And you just have to enable it, and it's just automatically delivered to you in your S3 bucket. Now, this gives you the overall cost. Now, the idea here is to basically divide that overall cost based upon this usage, right? So we will also show you like how we have done that little bit of math, and how we have kind of merge those two data sets together, right? So think about
Got
this
it.
as one data set, right? And think about this
Right.
as another data set, basically.
They have to kind of pull them together to
Yeah.
get those numbers for the consumption.
Yep.
One thing that comes to mind too as I look at this, it's as far as getting that information about the tenant into those microservices, it always comes back to SaaS identity, right? And why that
Exactly.
is so important that we talk about that, and that having not only user information but the tenant information throughout the entire process flow of your solutions helps you to get to this point.
Exactly, right. So I mean, let's just jump into that actually. Let's so without wasting much time, I'll just show you like the different microservices that we have built into this architecture to demonstrate the concepts, right? So we won't go too deep into the control plane aspects. It's kind of table stakes, right? That control
Right.
plane is needed for a SaaS application. We'll be focusing on the application plane, which is basically, so we have like 3 different application planes in this case. So one is serverless, as you can see, API Gateway, Lambda, DynamoDB. The second one is containerized workload, in this case, in a pool model where you have an ECS Fargate cluster with a single ECS service shared across all tenants, and a Aurora database shared across all tenants, right? This is also a containerized workload, but the difference being that we have one ECS service or one task per tenant and one S3 prefix per tenant, right? So these are some examples. And then, we'll talk about how we can visualize all of this in Kudos, right? So having said that, I'll kind of take a pause here and maybe Babak, let you jump into this lab too, the serverless one. Yeah.
Yeah. So I'm no longer.
One thing that I did want to mention here
Yeah,
too
please.
is that this is not an example of what we would necessarily recommend as an actual SaaS architecture, right? You wouldn't necessarily be building these out, per tenant with a lot of different infrastructure types, although it may, right, if you have an actual use case for it. But this really helps to demonstrate how we can get those cost allocation metrics from many different services.
Exactly. The idea was to show examples. And honestly, we couldn't get enough examples in here. I wish we could have added maybe Bedrock or EKS, and maybe we'll do that in future, right? But we just wanted to show different variants of different
Brilliant.
architectures. Yeah.
Yeah. Thank you, Anubhav. So yeah, Babak, you want to take over?
I'm no longer blurry, right? I think that was a ghost. I don't know.
I don't know. You look okay now. Yeah, either that or you got pulled out of the witness protection program.
Yeah. Okay. Let me know. My screen's on stage here.
Yeah. Let me. Actually, I don't see your screen share. You want to go ahead and reshare for me?
That's cool. Yep. Okay. There we go.
Okay. As soon as that comes up, I'll pop it up here. There we go.
Okay.
Oops. Hey,
Oh, yeah, there we
Inception.
More
Nice.
Halloween effects. Okay.
Yeah.
Okay, great. So yeah, as Anubhav mentioned, we're going to go into lab 2. So this will be in the workshop as well. This is the serverless SaaS architecture. Typical serverless pattern here. We got API gateway for our REST API. We're going to deploy our microservices in AWS Lambda, and then we'll have Amazon DynamoDB where we'll perform basic, create, read, update, and delete operations against. Okay.
Mhm.
All right, so taking a little deeper look in here, we're going to take both a coarse and a fine-grained strategy here. So at the API gateway level, we'll do a coarse-grained tenant usage strategy. So at this point, we're just concerned about how many times did tenant A call the product service, or how many times did tenant B call the product service or the order service. And then
when you say coarse versus fine-grained, Babak, what do you kind of mean by that, though, specifically?
Yeah, so basically, and for the fine grain, we're talking more like, when we invoke this Lambda function, what was the exact billing duration during that time, or what was the max memory usage?
So like very specific metrics that you're capturing.
For example, if we want to go into like metered billing, for example, we need to know those exact consumption metrics. At the DynamoDB table level, we're going to do the same thing. When we perform a CRUD operation, like what was the exact read or write capacity units that we used, okay? Now, regardless of whether we do fine or coarse-grained, as Anubhav was mentioning, we need to have some way to emit our logs and our metrics to be tenant aware, okay? So we need to have tenant context, and that's really where this kind of bottom half of this equation in the architecture comes in, right? And as you mentioned earlier, the SaaS identity and that whole portion, right? So typical SaaS workflow here is we have our tenant end users. They're going to sign in with an identity provider, such as Amazon Cognito. They're going to get their ID and their access tokens back, okay? And that JSON web token is going to have that tenant identifier. And that's what we're going to extract and be able to basically inject into our SaaS architecture all along the way, okay? And so that's really where this Lambda authorizer comes in. So let's take a little bit of a deep dive into what this is doing in the code. Now we've shared the GitHub link here, so you can go and clone this repo today and follow along. But for right now, I'll step you through this. This is the tenant authorizer code, and to take just a high level overview of what this thing is doing, it's going to obtain the JOT token here, okay? And then it's going to validate that token. And then the secret ingredient really here is it's going to extract that tenant context from the custom claims, okay, that we see here. And you'll see some of these to-dos throughout the code. This is actually one of the lab exercises that wants you to basically uncomment this code so that you can then start to see how we extract that tenant identifier coming in. We're going to move on here where we can then build a policy where we can generate STS credentials for fine-grained access control there. And then at the bottom here, we're just going to return this context object here where we're going to be caching in the temporary credentials here where we're going to use this downstream in our microservices. But more importantly, there's our tenant identifier, okay?
Mm-hmm. Yeah.
Now, going back to our architecture diagram, so we've kind of seen how this flow is working, where we've gotten our Lambda authorizer. Okay.
Yeah, this is a very, very typical SaaS workflow for this part, right? Yeah.
Exactly. I think of it as like SaaS 101, right?
Right.
So
Yeah.
one of the first things we talk about is how we manage this identity and getting the tenant context and the custom claims. Okay, so now that we're at the API gateway level, we're going to make some requests here. We want this to be coarse grain. So the coarse grain, again, usage is, we just want to know how many times, say, for example, a tenant is hitting one of our services, okay? And we can leverage API Gateway's access logs. So let's dive into a little bit more code and see how we're going to set this up with tenant context. So I'm going to jump over here. Again, this is available on the GitHub site. And this is the API Gateway code. This is an CDK. So this is our infrastructure as code. And when we set up our API Gateway, we have the ability to specify a custom access log format, okay? And again, the secret ingredient here, again, is right there, okay? So through this context object, this authorizer namespace, we can get the tenant ID. So to, as I kind of showed before, we were returning this context object, so we can reference those values there. And this access log basically gives us some, really nice usage information, basic information about the request, of what was the method, the status of it, what was the resource, and et cetera. So
there's other great metrics that we're gathering here too. That's not just necessarily cost per tenant, but could be used for other purposes as well.
Yeah, exactly. Monitoring and usage. And I'll show the log here in a second, but just to go back to our architecture. So we've gone ahead, we configured our Amazon API gateway to emit tenant-aware access logs. And this is what it's going to look like every time that we get a request. So if we look into our log group in CloudWatch, we can see there's our tenant-aware access log, right? So there's our tenant identifier. And then, of course, we have all this other, nice information like you mentioned. We got the response latency, the request time, method, and so on and so forth. Okay, so that's for that. And then we'll see later how we're going to basically aggregate this information and visualize it in Athena here shortly. Okay, so let's go back to our architecture diagram. All right, so we've kind of shown how we can obtain the coarse grain at the API level. Now, when it comes to the compute level, again, we want to focus a little bit more on the fine-grained usage here, okay? So, for example, what was the total duration that this Lambda function executed? What was the max memory? Now, if you're familiar with Lambda or if you're not familiar with it, the nice thing is after we invoke this function, we're given this nice platform report. So if you go into the log group of your function into a log stream, you'll see something like this, right? And we're getting some really good consumption metrics right out of the box. So we've got the billing duration in milliseconds, the max memory usage, and we can use this, to see exactly what each tenant is consuming, right? And be able to map that back to cost. So now the thing that we do not see here, right, is the tenant identifier, right? So how are we going to make this tenant aware? And this is where Lambda extensions come in. So I'm just going to give a really brief overview of this. This is the Lambda execution environment. And most people will probably be familiar with the main function runtime. So this is running your Python code, your Node.js, or your Java, or whatever it might be. But we also have the option to run an extension parallel to that function runtime. Now, for our purposes, what we're interested in is tapping into this telemetry API, okay? And that's going to allow us to get both platform telemetry, okay, which we saw here. So we can get our platform report, and we can get function logs coming from our main function runtime. And so we're going to get a little resourceful here. Is we're going to use both of those telemetry streams to then pretty much mash up the two and come up with a tenant-aware platform report. So let's dive into a little bit of the code, see how that works. Now, this is a little bit of deeper end of the pool, but again, all the code is there. All I want to do is just bring your attention to how we're processing this in the extension. So we have the telemetry streams coming in. So we're looking for function logs, and we're also looking for the platform report. And then we have a couple of methods up here that are going to take the information from both, again, join it on the invocation of the request ID of the invocation. And when it's all said and done, we're going to end up with a tenant-aware platform report that you see here. There's some embedded metrics format here. You can just ignore that for right now. But notice that we have the billing duration, right? We have the duration in milliseconds. So we got the good consumption metrics already out of the box there. The max memory usage, and more importantly, we have the tenant identifier right there. So we have a tenant-aware platform report. So that's how we're handling getting our fine-grained usage here at our compute level.
I have a couple of quick questions also that come in from the audience, Babak. The first one here is, oops, if I can get it to show, from Gagan. Gagan, welcome. And he was asking, can these workshops be done at home? And I think Anubhav mentioned this earlier. that the workshop is going to be debuting at reInvent, but afterward it'll be publicly available. Is that correct?
Yes, the workshop will be publicly available as any other workshop, right? So you should be able to do this workshop at home. And just keep a watch out on the GitHub repository. We'll update the link of the workshop in the GitHub repository in probably a couple of weeks. Yeah.
So you'll be able to run it self-service. Yep.
Excellent, thank you. And then also just one other quick question here is, why are we using CDK and not Terraform?
I know that CDK is going out of style and everyone wants Terraform. So, we're listening. So we hear you.
Thanks for the questions, Gagad. Yeah. Sorry, go ahead, Bubba.
Yeah, I know. Okay, so just to round this part out, we're going to dive into the DynamoDB. So again, we're going to perform fine-grained usage here, where we want to know what is the write or the read capacity units every time we make perform an operation here. So I'll just dive into a little bit of code as well. And let's open up the product service here. So within our get product method here, when we call the actual data access layer, I'll drill into that really quickly here. All we need to do for this, and DynamoDB makes this relatively simple, where when we call our get item operation, we can include this returned consumed capacity total to get whatever the total consumed capacity is for that operation. Okay.
Nice. Yeah.
And so within our response, when we return the product, we can also return back the consumed capacity, and then we would log that out as you see here. So I guess we have a lot of to-dos in here, and this is, again, part of the workshop experience where you uncomment this code and you redeploy it and then see it in action. And by the way, this is also going back to what we were talking about, the function logs. You can see that this is the function log that we're going to be printing out that's going to be captured by our Lambda extension. So you can see this little message that says this will be received by the Lambda extension through the telemetry API. And if I just drill into this one, you can see here we have just basic tenant log information, and there's our tenant identifier right there. And then we can pass in another dictionary here, such as like consumed capacity, that will print out any additional information. So if I go back to CloudWatch again, you can see that we have our consumed capacity as well in here.
Nice. It really does illustrate, though, that one thing that you have to keep in mind whenever you're building out your infrastructure or your solution for cost per tenant, it's going to be very dependent on what services that you're utilizing, right? As far as how to get this data.
Yeah, exactly.
Yeah, I think one important distinction here is the coarse-grained metrics, and the whole point of having coarse-grained metrics is to be able to maybe be service agnostic, right? Because we are using that API gateway across all of our microservices. So you can capture the number of APIs counts or maybe the latency of the API by just using coarse grain, right? And I think Babak will walk us through how those kind of looks like. But if you really are not into if you really don't want that penny to the penny kind of cost per tenant, right? If you just want an approximation, which is, by the way, is an approximation here anyways, right? So one thing which we really want to call out, maybe it's explicitly call out, is that the cost per tenant based upon this usage-based model is an approximation, and you really just want to be good enough, right? Is the idea.
Yeah. Okay. Great. So we've kind of completed this portion of it. We've seen how we're getting our tenant-aware usage metrics and logs in here. Okay. So now the idea is, well, what do we do with it? So we want to be able to attribute a portion of that total usage to each tenant. And this is where we now need to aggregate the data. I'm going to kind of just step it up here, not to take too much more time, but I'm going to open up just a little code here. So we have two different types of aggregators. We have a coarse grain aggregator and a fine grain aggregator. I'll just take you through a spin of the fine grain aggregator. This is going to run on a daily level. And what we want to do is we want to calculate that daily attribution. Okay. Now you can select your time interval. It could be hourly, it could be weekly, it could be whatever you want it to be. We're going to stick with daily here. And we're just going to do three major things here. We're going to aggregate the information using Cloud's log insights query using CloudWatch. So this is a good way where you can do kind of ad hoc queries on your log groups in CloudWatch. And you can see here, we're just going to basically aggregate this on a daily level by tenant ID, where we're going to use this stats sum function to build up the total usage for each tenant. Okay, and then once we do that, we're going to go ahead and we're then going to apportion that overall usage by tenant. Okay, so we're just going to do some simple arithmetic here and get what the percentage is. So have a look at that in a little more detail. And then lastly, once we have that information, we're going to convert it to a JSON file and throw it up on S3. Okay, and our bucket basically is going to look something like this. Okay, we're going to have a bucket for both coarse and fine grain. If I just drill into my fine grain here, you can see there is my JSON file. And then what we're going to do is we're going to basically throw a glue crawler at this bucket to then create
use something like Athena to then query this.
Yeah, exactly. So it'll create the tables for Athena. And then on that note, we'll jump over here. So you can see our tables are created here of our tenant usage. And if I go up here and run the query for the coarse grained, you can see we have our tenants on the left-hand side here. Our usage unit here is our API calls. So we see what the total usage is and what the portion for each tenant is. So we can see tenant one had 37.5%, the other one 30, about 33%. So it's a nice breakdown there, right? That's kind of basically those consumption metrics that we're after. And then now we can take our CUR report and then figure out exactly what the cost is, correlate our consumption with cost. For the fine grained, similar. Okay, so we've got our tenants down here. We were measuring the total consumed capacity and the total build duration. So we've got our fine grain for both the Lambda and the Amazon DynamoDB. And again, similar to what we just showed, after the breakdown, we can see, for example, tenant one used 33.3% of the capacity here in Amazon DynamoDB, then tenant two, 29%, and then 37%, and then for the build duration, kind of very similar. So that's all I have.
Awesome.
Yeah. So I hopefully that's clear, and yeah, definitely check out the code. And we hope to see you at reInvent here. I'll go ahead and I'll pass it off.
Thanks, Babak.
Awesome.
That was a really quick, nice overview.
Yeah.
For those of you that are joining late, and why are you late? You're on time. But if you are joining us late, thank you for being here. You're watching Building SaaS on AWS, where I am joined today with several solutions architects from the AWS SaaS Factory. And we're talking about cost per tenant and how to allocate your cost on a per tenant basis. So Mahesh, I think you're up next. Yeah, I'm going to talk about the next lab in sequence here.
Absolutely. So thanks, Babak and Anubhav. So the next lab is Lab 3, where we are going to discuss about a variation of an architecture, where we are going to have a containerized application running on ECS Fargate with using Aurora Postgre as a database, right? So I would like to recall some of the keywords Anubhav talked about, right? Tenant awareness, tenant context, and the challenges associated with the pooled model, right? So exactly in this lab, we are going to see how customers can solve those challenges associated with the pooled model in a similar architecture, right? Say, for example, here, the container is deployed in a single ECS service, which is running in a pooled model. And all the tenants are also going to use the database, in this case, Aurora Postgre SQL database, and the same tables which are going to be shared across multiple tenants. So in this kind of deployment model, there are challenges associated, like, for example, how are you going to associate a particular transaction to a particular tenant? That is one thing. And the second challenge that comes into picture is the tenant request is going to run the query in the database. How are you going to associate the query statistics and the query usage utilization for a particular tenant, right? This is a typical challenge any customers would come across, right?
Sure. Yeah.
So Before we go into the approaches on how we are solving this problem, let us have a look into the end-to-end of the architecture. So similar to the architecture of what Babak did it in Lab 2, the entry point, we will have the API gateway, Lambda authorizers, and Cognito, which is just a shared resources from Lab 2, where the tenant awareness is brought in by the JWT token, which will be passed all along to the ECS service. That's how you pass the tenant awareness or the tenant context till your application layer.
Similar process to what we saw with the serverless. Yeah.
Correct. So I'm not going to detail out what this Lambda authorization Cognito does, which Babak detailed out earlier. So now that request carrying the JOT token, once the authorization is complete, it gets carried forwarded to the ECS service running on a Fargate. So now, first thing is like you need to get the tenant ID from the JOT token, and second thing is in order to get the usage metrics in a pooled model, there is no silver bullet. So you need to have a proper instrumentation which can collect the usage metrics. In this case, we are going to use embedded metric format, AWS embedded metric format, which is nothing but a JSON specification for for structuring the metrics, which can be then used by the AWS CloudWatch metrics, right? So we'll have the application properly instrumented, which collects the metrics and pushes that metrics to the AWS CloudWatch, right? Once it is in AWS CloudWatch, similar to the approach which Babak mentioned, we'll have a Lambda aggregator, which collects those or aggregates those metrics from AWS CloudWatch and then pushes the usage metrics into Amazon S3, which will then be used by which will then be used for querying by using Amazon Athena. That flow remains similar to what Babak mentioned, right? So now that is the easiest part of the thing. So before I go to the Postgre part of it, let me show some code piece on how this instrumentation is done on the ECS service and how the aggregation works by using the embedded metric format. Okay. So this is the product review service. As you can see in this product review service, the first step is like we need to get the tenant context from the JOT token. That's what we are doing it here. The second part here, key important thing is the instrumentation. So remember that we need to collect the usage metrics. So the usage metrics that we are going to collect is the time, the execution time. So the instrumentation that we have done is like we need to determine the start time and the end time of the execution. In this case, we have an end time, and from that we will get the execution time, which will then again be pushed into the EMF logs. I mean, in an embedded metric format to the CloudWatch logs.
Right.
So there ends the instrumentation part of it. This is the 2 or 3 lines of code that you need to add to your application code so that you have metrics emitted. That is the first part of it. Once the metrics are emitted, you need to aggregate those metrics on a daily basis or on on a particular frequency, so that you can have the usage per tenant, right?
Makes sense. Yep.
For that, we have this ECS usage aggregator as part of this lab. If you look into this code piece of it, what it does is it queries the CloudWatch metrics, which is the embedded metric format which we emitted, and collects the execution time or aggregates the execution time by tenant for that particular tenant. So ultimately, what we are doing here is we are summing up all the execution time for the day. Let us assume that you are running it daily for that particular tenant. And once we collect or aggregate those metrics, we will push that to the S3 bucket, which is there for the tenant usage.
Similar to the serverless.
Similar to the previous lab. Correct. So once it is there into the S3 bucket, and we will use the same Athena query, or we will use Athena to query the ECS usage. So for example, in this case, this is the ECS service. For the ECS service, we have the execution duration for each of the tenants in the system, right? And we apportion that into a tenant percentage like this. So now what you have in hand is an absolute execution duration seconds for every tenant and apportion that to a percentage. And this percentage usage metrics will be used in lab 5, which Anubhav is going to detail out, along with the cost and utilization, cost and usage report to attribute the cost per tenant for the ECS usage. That's
Got it.
how the labs are going to evolve, right? So,
Yep. Sorry.
any questions? Any question,
No.
Anthony? Yeah.
No. Please go ahead.
Yeah. So now that we are done with this piece of the thing, which is the application layer piece, we will now get into the database piece. This is a puzzle that we need to solve. So now that, database doesn't have the tenant context, first of all, we need to solve that problem. In order to solve that problem, what we have taken is a database user per tenant. Once you have a database user per tenant, you will be able to associate any or collect the metrics, necessary metrics from the database for the database user. Remember, we are following the database user per tenant. That's how we solve the piece of this puzzle with respect to database.
That
So now
allows
that-
you to make that connection to the tenant when accessing the database.
Correct. So when the application accesses the databases, it will use that database user associated to that particular tenant. Remember that in the application, we have the context of the tenant. For that tenant, we know what is the database user in the metadata. And using the database user, we will connect to the database, right? And execute the query. And once you establish that traceability or the tenant awareness in the execution of the query, all of the statistics with respect to the query execution, you can collect it at the database user level, which then maps to the tenant. That's how we solve the piece of the puzzle, right? So once you do this, right, database per user and any of the transaction is at the database user level, we have a native feature called Amazon RDS Performance Insights, which is natively available for Amazon Aurora Postgre and MySQL, and also available for RDS Postgre, MySQL, MariaDB, SQL, and Oracle, right? This feature, you can use it for these engines. And with that, you will be able to get the database load per database user. Remember, database user is nothing but tenant. So now the puzzle or the problem is solved. So you will get the exact database load by database user, which then maps to the tenant, and hence you get the database load per tenant. That is the metrics that we will be collecting. And once we collect it, again, we will use a Lambda aggregator, which aggregates at the daily level or the stipulated frequency and push that to S3, which will then be used for your usage statistics. Okay, that is one part of it. I will quickly show the code for the DB load part of it. So this is the piece of code we have where we have APIs to collect. Since it's a native feature, we have API to collect the DB load resource metrics. Once you collect it, you aggregate it. Rest of the codes are for aggregation. And finally, you push the metrics to the S3 part of it. So remember here, the usage unit is there, which is nothing but the DB load, and then we push it to S3. Once it is in S3, and again, we will use the Athena to query the data. So if you see here for Amazon RDS, we have DB load, which is attributed for each of the tenants in the system, and you will get the percentage of DB load attribution.
Wonderful.
Correct?
Yep. Now, time is flying by so fast here, Mahesh, and thank you so much for bringing us here. But I want to make sure that we can talk also about how we actually visualize this, right, and actually see it. So,
absolutely.
Yeah, Anubhav, maybe we can bring you back on to talk about how we actually can see this.
Yeah, and as Mahesh mentioned, like we have done different ways of capturing RDS metrics. So just look at the code around how he's capturing the blocks written, right? IOPS and all that stuff, right? So all of that code is also in the. So hey, I know we're running out short of time, so so jumping quickly to the visualization part, right? So what we did was we actually leveraged the cloud intelligence dashboards to visualize our cost per tenant. Cloud intelligence dashboards, which Kudos is part of. So if you might have heard about Kudos, it's basically a tool to visualize your AWS cost, right? So our approach was, okay, you know what, let's just deploy Kudos and Cloud Intelligence dashboards and just add the cost per tenant metrics to those dashboard itself, so that you get a full picture of your AWS cost and cost per tenant, because those are all obviously related to each other. Now, the benefit of deploying Cloud Intelligence dashboard is that you get some things by default. So what you get by default is a cost and usage report configured in your AWS account, which is pushed to S3. And then those installations of dashboards also configure all the Athena tables to query your cost and usage report and visualize in QuickSight, right? So we kind of piggybacked on this kind of infrastructure and added on top of it, right? So then just to give you a quick peek into what Kudos deployed for us, right? So it basically created this data export, which is basically the car export into an S3 bucket, right? Now, one more thing that you should be doing is enabling the cost allocation tags, right? So if you remember, like, we have different microservices, and all those different microservices are putting some tags into the cost and usage in basically as putting some tags into the AWS resources. So now, in order for those tags to appear on your cost and usage report, you actually need to enable them in this cost allocation tags screen as well. And the reason it is important is because now you can see those inside your views that has been created by the Kudos dashboard, right, installation. So by the way, these are all your tables and views that were deployed when you installed the Cloud Intelligence dashboards. And if I just run a distinct SaaS service tag, you will see that I have from the bottom a tenant management tag, which is basically the tag associated with the control plane. App plane shared is also the shared infrastructure for my application plane. So these two tags are for my shared services. If you go back to that diagram I showed you, right, the control plane and the application plane, right? And these are the three tags that we use for our microservices, the lab 2, lab 3, lab 4 microservices. So now we are able to first see a quick breakdown of the cost of the shared services by just making sure that we query on those two tags, the shared app plane shared and tenant management tags, right? And you can just see, okay, this is your monthly usage. So it's obviously very low because we are using serverless services and we are not having too much usage. So, but you can still get to that shared services tags. Now, the interesting aspect is when you start combining your usage for your features, basically your application plane and the cost of the application plane. So now what I'm doing here is that this query basically gives me my overall cost of my application plane because I'm filtering down on those cost allocation tags, right? So if I just run this query right here, this is basically my daily SaaS amortized cost for this date, right? So for this date, this is my total cost. For this date, this is my total cost for my application plane because I'm able to filter down by those tags for my application plane. And then, if I just run this whole query right here, you will see the breakdown of that cost based upon coarse grained metrics. So if you remember, we collected those coarse grained metrics into Athena, and it's a simple join on date, basically, right? It's as simple as that. And then we are leveraging the usage metrics that we collected to break down that daily cost by tenant. So if I just break it down, and I know that we are running short of time, so I'm just trying to make sure that I just do the best I can. But
No worries.
basically, if you just see here, it's the total API count and the total cost. And then for each tenant, you see a breakdown of those API counts and cost. Basically, it's as simple
It's
as
more
that.
incentive for them to come see us at reInvent. I love it.
Yes, yes. Now, I will not go into the fine-grained, which is basically the same query, but done at service level, right? I'll just quickly run and show the output, right? It's the same thing, but now you can see the breakdown by service as well, right? It's the same output, and all these queries are available in the workshop for sure. Now,
what is that field that we had a question about the
mhm.
tenant % API count
It's
metric?
basically the percentage of APIs by the tenant. So let's say you have total APIs 500 for your SaaS application. So total number of times your SaaS applications was hit like 500 times. Out of those 500 times, how much was tenant
What's
one?
the
How much was
percent?
tenant two? It's
Got it.
basically the percentage usage for each tenant of the overall SaaS consumption, right?
Got it.
Now, basically, if I just look at the dashboarding part of it, right? So what we did, we extended the Kudos dashboard. So what you see here is the entire Kudos dashboard, which is basically used to observe your overall AWS cost. Um, you know, you can use this deployment instructions to deploy those Kudos dashboards. So that's a separate workshop of its own, how to do that. Maybe we can share the link of that as well, Anthony, right? But what we did, we added a new tab called SaaS cost attribution to those Kudos dashboards, right? And what we did was we added those two data sets that we created for coarse grained and fine grained, which I just ran the queries on, into this dashboard. Right. So now what you can see here is a breakdown of your overall AWS cost by tenant. And the reason I'm able to do that is I just created a simple pie chart here and added a group on tenant ID and the cost as your value, right? So it's basically very simple chart. Obviously, you can add a filter for
Do a
date
lot
as well.
more than that, right?
Yeah, I mean,
Sure.
this
I
is
mean,
like
you
a
could go
very, very
crazy with these, man.
basic start. You can
Yeah.
add a filter by date, or you can add a date range, or you can add a tenant ID filter. You can also add like a feature filter if you want, because the coarse grained metrics also capture the feature as well at the API gateway level. And then on the other side, we have this fine grained, which this is basically the view or the quick set dashboard for that, right? And in this case, I see a breakdown of my overall cost of my product review service, right? Remember the lab 3 which Mahesh
This is
showed
on a
us.
per service basis at this
This
point,
is
right?
on per service, per feature basis, right? Per microservice basis. And again, you have flexibility to kind of, maneuver the metrics in whatever way you want. And here you see the usage and cost breakdown by service. So I'll just, leave it there, Anthony. This is a quick
Yeah,
review.
we had to go so fast here. We're trying to fit in, a 2-hour workshop into less than an hour. So I just want to say thank you so much, Anubhav, Babak, and Mahesh for being here today and showing off this really great new workshop. Again, this is going to be publicly available, so anybody that's interested in it as we get after reInvent certainly can do so on your own. And come and see us at reInvent if you're going to be there. We'd love to have you. Thank you all for being here again. And as we move forward into next year, we will be planning out more and more episodes. We do have a couple more left in this season, however, including 2 weeks from now. So be sure to join us then when you can, or if you can. For all of us here at AWS and the SaaS Factory, thank you for joining us, and I'll see you all builders on the next episode of Building SaaS on AWS. Bye-bye now.